Hi students, I hope that you all are safe. The question is if A1, A2 and so on are in arithmetic progression 1 by square root A1 plus square root A2 plus 1 by square root A2 plus square root A3 plus so on plus 1 by square root of AN plus square root of AN plus 1, then n is equal to, okay, then n is equal to, and we know that. Now we have to know the concept of arithmetic progression over here. If A1, A2, A3 and so on AN, okay, AN are in arithmetic progression. So the basic concept for this arithmetic progression is the two successive terms has to be differ by the same quantity. Then we can write it as, so that means A2 minus A1 difference between, and A3 minus A1 and so on. So all the differences, these are differ by a common difference D. Okay, then what it is, an minus a n minus 1. Okay, these all are differ by a common difference D. Okay, so now if we go on the process, and we can write a2 is equals to a1 plus D, and similarly a3 is equals to a1 plus 2 times of D, and in so on. Finally the term an can be written as a1 plus n minus 1 times of D. This is the nth term in arithmetic progression. Okay, an for the given nth term an, we can write it as a1 plus n minus 1 into D, whereas the common difference is a2 minus a1. The two successive terms differ by the same quantity, that is the arithmetic progression. Now moving forward to our question. So now what is given, 1 by square root of a1 plus square root a2 plus 1 by square root a2 plus square root a3 and so on. Finally we are over here 1 by square root, we can write this is as an plus square root an plus 1. Okay, square root an plus 1, and this can be solved with the help of by rationalizing the factors. So how to be it is, we can write this is as 1 by square root a1 plus square root a2. Now we know that in this arithmetic progression a1 a2 an, so a2 is greater than a1 and a3 is greater than a2. So while making this one, just with rationalize with square root a2 minus a1 by square root a2 minus square root a1 plus, okay, the next term 1 by square root a2 plus square root a3 into, now the rationalize with square root a3 minus square root a2 by square root a3 minus square root a2 and so on. If we go on over here, the nth term, the last summation will be square root of an plus 1 plus an square root an into, now we have to rationalize with square root of an plus 1 minus square root an by square root of an plus 1 minus square root an. Okay, so now if we go on the simplification, what we'll get over here, square root a2 minus square root a1 by, so the first term it is in the form of a plus b into a minus b. That means we can write this as a2 minus a1 plus square root a3 minus square root a2 by, then we can write this as a3 minus a2 plus so on. Finally we will get this is as an plus 1 square root an plus 1 minus square root an by, we can write this is as an plus 1 minus an. And we have discussed that a2 minus a1, a3 minus a2 and an plus 1 minus an, the successive terms are differ by the same quantity. Now this can be written as a2 minus a1 and a3 minus a2 and an minus an minus 1 and an plus 1 minus an. These all are differ by the same quantity, that is the common difference d. Now I can take 1 by d as a common over here. Why? Because this is d, this term denominator, all the denominators are d. Then if we go on this one, square root a2 minus square root a1 plus square root a3 minus square root a2 and plus, now over here I will get square root a4 minus square root a3 and so on. Finally the before term, what is the before term? Square root an minus square root a n minus 1, square root a n minus 1 plus square root a n plus 1 minus square root a n. If we observe over here 1 by d into, now in the first term come to the second term, the first term in the first term and the second term in the second term. Okay, the first term in the first term, the second term in the next term, first term in the term, second term in the next term, and go on over here. The first term, okay, the first term in this one, second term in this one. Okay, so similarly now the second term will be cancelled out. Okay, now the second term will also be cancelled out. Then what we'll get over here? Square root of a n plus 1 minus square root a1 we will get over here. Square root a n plus 1 minus square root a1. So now we have to retrieve the term d. Okay, we know that just we have seen over here. I am doing over here what it is. A n can be written as nth term in an AP, first term plus n minus 1 into d. Now what is the a n plus 1 term? So which is nothing but a1 plus n is replaced by n plus 1 minus 1 into d. Then we will get a n plus 1 is equal to a1 plus n times of d. Then a n plus 1 minus a1. Okay, a n plus 1 minus a1 is equals to n times of d. From this one we can write d equals to a n plus 1 minus a1 by n. Okay, a n plus 1 minus a1 by n. Now replace the d over here. Then we'll get over here is as square root of a n plus 1 minus square root of a1 by, and what we'll get over here, a n plus 1 minus a1 by n. Okay, a1 by n. Now if we further simplify this one, we will get this is as equal to square root of a n plus 1 minus square root a1 by, so now over here we'll get into n by what it is, a n plus 1 minus a1. We can write this is as square root of a n plus 1 plus square root a1 into square root of a n plus 1 minus square root a1. So we'll get the denominator. This is in the form of a plus b into a minus b, a n plus 1, a square minus b square, a n plus 1 minus a1. Then we'll get over here this a square root of a n plus 1 minus square root a1. Square root of a n plus 1 minus square root a1 will be cancelled out. Then the resultant is n by, okay, n by square root a1 plus square root of a n plus 1. Okay, which is the final result. So look at the options. If we look at the options, what we'll get over here, what is the answer? N by square root a1 plus square root a n plus 1. Okay, n by square root a1 plus square root n plus 1. Then option A is the correct one. I hope that this answer will help you to get the required solution. Thank you. The next question is given that a club has 256 members, okay, of whom 144 can play football, 123 can play tennis, and 132 can play cricket. Moreover, 58 members can play both football and tennis, 25 members can play both cricket and tennis, while 63 can play both football and cricket. If every member can play at least one game, then number of members who can play only tennis is. Okay, here he has given that every member is playing a one game, so that means the total number of members who can play either tennis, football or cricket, that is totally 256. That means he has given the total number of players is 256. Okay, n of s is equals to 256. That means they combinedly all together can play totally of 256 members. Then now what he has given, the number of players who can play football, I am representing with f. Okay, the number of players who can play football is 144. Next, the number of players who can play tennis, I am representing with capital T, that is 123. And the number of players who can play cricket with C, that is 132. Okay, this is the required given information he has given. And further, what he has given, the further information is the number of players who can play what it is both the games, what it is here given football and tennis. Football and tennis who can play is 58 members, and the number of players who can play both what is tennis and cricket. Okay, tennis and cricket is the second one, he has given 25, and the number of players who can play football and cricket is equal to 63. Okay, first of all, we know that the formula, what it is, number of total s, n of s can be n of f plus n of t plus n of c, that means cricket, minus what is football intersection tennis, minus tennis intersection cricket, minus tennis intersection cricket intersection football, plus the number of players who can play all the games, all the three games, that means who can play football, tennis and cricket. Okay, so by replacing the things over here, first of all we have to find the total. He has given 256. From this one he has given n of f is 144, then 123 plus 132 minus, then we can write this is as 58 minus 25 minus 63 plus, we have to find the players, how many players can play all the games, all the three games, football, tennis and cricket. From this one we can write this as 256 minus or equals to, then if we add all these, what it is, we'll get 4 plus 3 7 9, 5 plus 9 399 we are getting. I am replacing over here, it is as 399 minus, now we have to add all these 58. If we take minus as a common over here, then we have to add what it is, 5 plus 3 8 16, means here it is 6, 5 plus 2 7 plus the 6 13 plus 1 146 plus the number of players who can play football, tennis and cricket. Okay, the three games can be played, and if we write this is as 256 equals to, over here we will get it as a 253 plus, finally we'll get from this result as the number of players who can play the three games, what is football, tennis and cricket, is equals to 256 minus 253, then we will get the three players are playing all the games. Now we have to be, okay, now moving forward with the help of the, okay, with the help of the Venn diagrams, now we can able to get the results. Okay, with the help of the Venn diagram we are able to get the results. Okay, now here he has given that let this circle represents the number of players who can play football, this is tennis and this one is the cricket. Okay, from the one, all the three games who could play, this is the region where the three can play is, it is totally three players, but we know that how many can players can play football and tennis, it is 58. From the 58, three players are already playing three games, then the portion here we need to consider this is as a 55. And similarly tennis and cricket, here we have 25 already, here the 3 is over, now it has to be replaced by 22. Now coming to cricket and football, the players are playing 63 totally, cricket and football. Okay, cricket and football, this is the region, totally 63, but 3 already given, the only football and cricket will play 60 members. And the question is asking us how many members can play only tennis. Okay, the tennis, who how many members can play only tennis. Now this is the portion to find out the tennis. We know that the number of players, okay, the number of players can tennis play is given that 123. Okay, the number of players who can play tennis is given that 123, but in this one, so from the 123, total of 123, so 55 members plus 3 plus 22. That means here we'll get 55 plus 25. 55 plus 25 we will get EIT. Okay. So the EIT players can play. Okay, the EIT players can play. Now these are the players. The EIT players can play. Okay, not only the tennis, but they can play either football or tennis or cricket. Okay, now if we remove these EIT players from the total of 123, okay, then 123 minus EIT, that is equals to 43. Okay, now the only 43 is the portion represents those can only play tennis. Okay, they cannot play any cricket or football. Okay, they cannot play cricket, they cannot play football, only they can play tennis. So the answer, required answer for this solution is, what is the solution? 43. Then option B is the correct one. 43 who can play only tennis. Okay, I hope that this answer will help you to find out the solution. Thank you. So the next question is, if the population of a town is P in the beginning of any year, then it will becomes 3 plus 2p in the beginning of the next year. If the population in the beginning of 2019 is 1000, then the population in the beginning of 2034, okay, 2034 will be, okay, right. Here he has given that he has given the four options. These type of questions can be verified with the options. It is the best choice to verify with the options. Okay, now we'll look at over here in 2019. Okay, in 2019 we have the population is 1000. Okay, that is a start of the year, this will be P. And next year, that means for example for the 2020, okay, 2020 the population will be 3 plus 2p. Okay, 3 plus 2p, that means 3 plus 2 times of p is nothing but 1000. Now if we write over here, it is what we can write, this is as 2000 plus 3, 2003. Okay, so can we apply this to the any one of the options? Can we apply this to the any one of the options for the year 1? Okay, for the year 1, now I can apply this one to the as 1003 into 2 power 1 minus 3. Okay, 1003 into 2 power 1 minus 3. Whereas the starting year, I can write this is as 1003 into 2 power 0. Okay, at the starting year I am mentioning with 0 minus 3. Okay, then what I will get, 2 power 0 is nothing but 1. 1003 minus 3 is I am getting it is as a 1000, and the 2003 for the 2020 year I am getting it as 1003 into 2, that means 2006 minus 3. And for the 2021, what it will be, another 3 plus 2p, means nothing but 3 plus 2 into, now the p will become, the before year is 2003. Okay, so now the resultant will be is equals to 4006 plus 3 4000. Now can I summarize this in this manner? Okay, now 1003 into, I can write this as 2 square minus 3. That means I am getting 1003 into 4, 4012 minus 3, I am getting it as a 4009. That means now we are getting this is as 1003. Okay, sorry, I am writing over here 1003 into 2 power. Okay, 2 power. What I am getting at the 2019 year, I am getting it is as 2 power 0. At the 2020 year, I am getting it as 2 power 1. And in the same manner, if I go for 2034, what I will get? Okay, including the 2015, it is total count is 16. Then I can write this 2 power 15 minus 3. Okay, just look at the things, the generalization we are doing over here with respect to the options. Okay, the generalization here we did it as from 1003. At the initial stage it is 1003 into 2 power 0, so starting here it is 1, 2000 to 2 power 0 minus 3, again we are getting 1000. And with respect to the option he has given, what he has given at the next year, it is 3 plus 2p, that means 2003. That means we can generalize with 1003 into 2 power 1 minus 3. For the next year it is 1003 into 2 square minus 3. For the next year it is 1003 into 2 cube. Okay, for the 2022, what we'll get, the population will be 1003 into 2 cube minus 3. For 2023 it will be 1003 into 2 power 4 minus 3, and so on for the 2034. Okay, for the 2034 we will get 1003 into 2 power 15 minus 3. Then option C is the correct one. Okay, this is the way of going with the what it is with respect to the options, how we are verifying this one. I hope that this answer will help you to find out the required solution. Thank you. And now before we analyze the same question with the help of, we solve the same question with the help of the regular, what is the simplification, but how to do with the regular procedure. Just we have gone with the options before solution. Now the method 2 we have to do is, what is the method 2? In 2019 we have the population is p, and what is the population in 2020? He has given that 3 plus 2p. Okay, 3 plus 2p. And in 2021, what is the population? 3 plus 2 into, now this is the population over here, the p must be replaced by 3 plus 2p. Okay, are you getting? So this is nothing but, in the previous year population, that will be 2 times of 3 plus 2p, the population will become 3 plus 2p, but p now is 3 plus 2p. Now if we go with this one, we can write this as 3 plus 2 into 3 plus what will get 2 square into p. Now in 2022 the population will be, now this will be the population for the previous year. Now we can write 3 plus 2p. P now it is nothing but 3 plus 2 times of 3 plus 2 square p. Okay, so now the population is 3 plus, and it is 2 into 3 plus 2 square into 3 plus 2 cube times of p. Okay, now it is the 2019 year. The next year, okay, it is 3 plus 2b. The next year it will be 3 plus 2 into 3 plus 2 square p, and the next year it will become that, like that is the third year. Third year it will be 3 plus 2 into 3 plus 2 square into 3 plus 2 cube into p. In the same manner, from the 2019, what is the population in the 15th year, that is 2034. Now we can write in this manner as, what it is, 3 plus, okay, 2 into 3 plus, and 2 square into 3 plus, and we can write this is up to 2 power 14 into 3. Okay, we can write up to 2 power 14. Why? Because the third year it is 2 square, that means 3 minus 1. The 15th year it is 2 power n minus 1, 15 minus 1 into 3 we obtain over here, plus next what we are getting, the third year it is 2 cube into p, in the 15th year it is 2 power 15 into p. Now if we take 3 as a common, then we'll write it as 1 plus 2 square plus so on 2 power 14 plus 2 power 15 into p. Okay, now it is 3 into, now this is geometric progression of a finite series. Then we can write a is equals to 1 and common ratio equals to 2, and a into r power n plus 1, that means 14 plus 1 r power 15 minus 1 by r minus 1, 2 minus 1 plus 2 power 15 into p. Okay, now if we simplify this, what will get? 3 into 2 power 15 minus 1 plus 2 power 15 into p. Then we can write this as 3 into 2 power 15 minus 3 plus 2 into 2 power 15 into p. And if we take 2 power 15 as a common, then we will get p plus 3 times of 2 power 15 minus 3, whereas p is nothing but given as in the 2019 year it is 1000. Then we can write this is as 1000 plus 3 into 2 power 15 minus 3. Then the solution is, finally we are getting it is as 1003 into 2 power 15 minus 3. I hope that this answer will help you to find the required solution. Either we can go with the regular what is from the options to generalize what is the 0 years population, what is the first year population, and what is the second year population. In this manner also we will verify. Otherwise with our regular procedure also we can find out the solution. And thank you very much. I think this answer will help you to get the required solution. Thank you.